Grant your bride one wish on this night.
You have but to ask. Anything.
I want to kill the unicorn.
If you're missing this 86 movie, then there's an important piece of Tom Cruise's repertoire that you're missing out on. We are almost done. We want to talk about how to do confidence intervals with regression, and there's another one that we'll pick up in a new video coming up. To help you understand what this video is going to be about, I want to grab this prediction equation here, and instead of using RStudio, I'm going to switch to regular R for the simple fact that I want to do a whole lot of pictures and I don't want to break my computer's memory by having it try to remember them all. And I'm going to draw the same red line that we had before. And I'm going to tell the computer to randomly make some data in the same way that the real data was structured. The code for that I'll talk about in a later video. But if I ask the computer to randomly make the data and plot it, you'll notice the dots look pretty similar to what we were seeing before, even though it's randomized, so they aren't exactly the same. Here's the interesting thing. I made these dots fit this regression line, the red one for real, but if I analyze those dots, what I get from that random data is a line that doesn't exactly match up with the red line. Why is there a difference? Well, just because randomness in the data. If I did it again, I get a slightly different data set and a slightly different line from the data, this purple line. Actually, this one looks a little closer than it was before. Let's run it again and see what I get. Before it started out a little above the red line, now it's a little bit below the red line. Every time I do this, I'm getting a slightly different purple line. And if I automate this to sit here and do a whole bunch of these, you'll see that over and over, using data made with the red line, I'm getting purple lines that are just a little bit different each time. It's also interesting to notice that the purple lines aren't that different from the red line, only a little bit different from the red line. So when we talk about a confidence interval for the regression line, we're not talking about how spread out is the data or how far is the data from the regression line, but how much could the regression line wiggle? How much steeper could the slope be due to randomness in the data, or how much less steep could, oh look, right there was one that was less steep due to randomness in the data. Going back to the data set we were looking at before, that's what this number right there tells you. This slope is a 1.89, but it could be 0.08 higher or 0.08 lower, depending on the randomness in the data. So we can use that information to make a confidence interval. And in fact, some introductory stat classes have you use that and create the confidence interval. We don't need to though, because we can ask R to just do it for us using the confint command. That stands for confidence interval. When you run this command, it will tell you a confidence interval for the y-intercept, which we don't care about. Here is a confidence interval for the slope, and that we do care about. That slope could be as low as 1.71 or as high as 2.06. In other words, that's how steep or less steep that slope could be due to just randomness that we see in the data. Please keep in mind, this is how we talk about a confidence interval of the slope. Over here, this is how we would do a confidence interval for a mean. And those two are different, slope versus mean, so don't get that confused.